Welcome to The Explainer, where we're going to pull back the curtain on one of the most powerful concepts in our modern world, the computer program. You know, here's a wild thought. You've probably already used a dozen computer programs today, and you didn't even realize it. Seriously, from the alarm on your phone to the app you checked for the weather, they're all powered by these invisible engines that are quietly running our daily lives. So that begs the question, right? What is a program actually? How does this invisible code really make things happen? Well, let's break it all down. And we're not just talking about the little things. I mean, think about the big stuff. The shows you stream on Netflix, the things you buy from Amazon, heck, even the incredibly complex systems that are guiding cars and flying airplanes, it's all run by programs. So the best way to wrap your head around what a program is, it's not with some crazy complex diagram. It's actually a lot simpler. Just think about something you'd find in any kitchen, a recipe. And that's really all there is to it. A program isn't magic. It's simply a list of instructions for a computer to follow, one step at a time, exactly like a chef follows a recipe. And when you look at them side by side, it's kind of wild how similar they are. On the left, you're telling a person how to combine ingredients. On the right, you're telling a computer how to combine numbers. But in both cases, it's just a clear step-by-step sequence to get a very specific results. Now get this, no matter how complex a program seems, whether it's a simple calculator on your phone or a massive video game, it's almost always built from just 3 fundamental actions. That's it, just 3. So here's the secret sauce. First, the program takes in some information, that's the input. Then it does something with that information, that's the process. And finally, it shows the result, that's the output. Input, process, output. Remember that, because it is the foundation of almost everything. Okay, theory is great, but let's actually see this in motion. We're going to watch a very simple program run, one instruction at a time, so you can see exactly how a computer thinks its way through a problem. Now, to do this, our program is going to use something called variables. Don't let the word scare you. Just think of X, Y, and Z as little labeled boxes that the computer uses to store our numbers for a moment. All right, here we go. The program starts at the very first line of its recipe, which says, "Get next input." This is our input step. So, let's just imagine we type the number 2 on our keyboard. Perfect! The computer grabs that 2 and puts it into the little box labeled X. Now it moves right down to the next instruction, which is to get another input. Okay, let's give it the number 5. Great, so now the Y box is holding the number 5. The computer has both of its inputs. And now for the magic in the middle, the process step. The program follows the next instruction, which is to add the value in box X to the value in box Y. So it does the math. 2 plus 5, that equals 7. The computer takes that result, 7, and stores it in our last variable box, Z. It's now holding the answer and it's ready for the final instruction. And here it is, the final output. The program follows its last instruction, put the value from Z onto the screen. And boom, there it is, 7. We've just completed the full cycle, input, process, and output, all one simple step at a time. Now, this is the most important part. This methodical, step-by-step way of doing things isn't just for computers. It's an incredibly powerful skill for us to use in our own lives, too. You know this recipe we've been talking about? This sequence of instructions that solves a specific problem? Well, it has a formal name. It's called an algorithm. And here's the best part. You do not need to be a computer genius to start creating them. You just need to practice breaking down problems into smaller, manageable steps. This skill actually has a name. It's called computational thinking. All it really is breaking down big, complex problems into smaller, sequential steps. For example, imagine you had to write a recipe for a little robot turtle to draw a triangle. How would you do it? You wouldn't just tell it to draw a triangle, right? It wouldn't understand. You'd have to create an algorithm, a precise recipe. You tell it, okay, first put your pen down, then move forward 100 steps. Now turn left 120 degrees. You see? You break the big goal into tiny commands that the turtle can actually understand and execute. And this way of thinking is becoming absolutely essential. You know, just like reading and math were fundamental skills for the industrial age, many believe computational thinking is becoming just as critical for navigating our modern world. So the next time you face any kind of complex task, try thinking like a programmer. Ask yourself, what are my inputs? What's the step-by-step process I need to follow? And what is the final output I'm trying to get? Once you start looking for them, you'll realize that these simple recipes, these algorithms, are truly the building blocks for solving almost anything.